Hey guys, welcome to week 5, where our goal today is to use the compound interest formula to solve problems. So we have a little throwback to year 9 here, where you first were introduced to the compound interest formula. And I do promise that while it might seem a little bit out of place with our exponential equations topics, it's actually not, and we'll see that next lesson. Starting with the warm-up, I want you to evaluate these two equations for x using logarithms, and make sure you upload those to OneNote, please. So last year we looked at compound interest, and you may recall, or you may not, that the compound interest formula states this: that the amount of money after investing a principal amount at rate R for n periods can be calculated like so. So A is equal to P outside of 1 plus R on 100 to the power of n, where A is the final amount of the investment, P is the initial amount you invested, R is the interest rate as a percentage per compounding period, and n is the number of compounding periods. The compounding period is just how often it compounds and pays you out interest. So let's get stuck into an example. Let's consider a $4,000 investment. We want to determine the amount after 5 years if $4,000 compounds annually at 8%. Round to the nearest cent. So here's what we do. We write in our equation to the power of n. Now we are investing a principal amount of money of $4,000 at a rate of 8%. And we divide it by 100 as part of the formula, guys, but you're welcome to do that in your head if you want to. All right, that's just getting it to a decimal to be workable. To the power of n, which is the number of compounding periods, it compounds annually for 5 years. So that means it compounds 5 times altogether. If we evaluate that with our calculator, we end up with the with the total $5,877.31. So have a go at this one here in blue. Determine the final value of an investment after 6 years if $3,000 compounds annually at 7%. So you're going to have a very similar situation to this, and this is just a review of using this formula. You should get this answer down here in purple. Let's do 2 more problems. So sometimes we don't always compound annually, which is much more indicative of what we experience in actual banks here in Australia. So let's have a look at what this question's asking. Calculate the number of periods and the rates of interest offered per period for the following. Okay, so here, if we're looking at the first one, we've got 6% per annum over 4 years, but it's paid monthly. What that means is the rate is going to be the 6% broken into 12 increments, because there's 12 months in a year, which means the rate is actually 0.5%. Similarly, the number of compounding periods, if we compound for 4 years every month, that's 4 times 12, or 48 times altogether. So have a go at this one now. Hopefully you'll get that the answer for R is 4.5%, and your answer for N is 12. One final question for today, all right, is determining the amount of a compound interest investment compounding monthly. So Anthony's investment of $4,000 is compounded at 8.4% per annum over 5 years. Determine the amount he will have after 5 years if the interest is paid monthly. So we're going to have to consider what we considered above. We're going to have to divide the rate by 12 and multiply our number by 12. So let's write our formula. A is equal to P1 plus R on 100 to the power of n. In this case, we've got 4,000, 1 plus, now we've got 8.4 on 100 But we also have to divide it by 12 because that 8.4% is getting paid out over 12 months. So when we divide the 8.4 on 100 by 12, that's just the same as putting the multiply by 12 on the denominator. To the power of, well, we're not only compounding for 5 years, but 12 times per year. If I pop all of that into my calculator, and guys, I do, where possible, do keep everything in one step. That way you're not rounding or getting any rounding error. If we do all of this, we end up with Anthony's investment equaling $6,078.95. So there's a similar one here for you to have a go at. You've got $7,000 compounding at 6.2% per annum for 4 years. Determine the final amount of the investment if the interest is paid monthly. So you're going to have to consider, that your number of compounding periods is 4 times 12, and that you're going to have to divide your 6.2% by not only 100 to get it as a decimal, but also by 12. You should get the answer $8,964.49. With that, we want to consolidate this understanding. So hopefully it feels like a blast from the past, guys, just from year 9. Just want you to have a go at these few questions in exercise 3L. And if you have any questions, make sure you email me. Thanks.